So in this video, we will talk about suppliers. We know that in order to use Lambda expression, we need a functional interface, but we don't really need to create functional interfaces for all the tasks. There are so many functional interfaces shipped with JDK, and we can find them in java.util.function package. So there are quite a few functional interfaces already developed and shipped by the Oracle. All we need to do is we need to find an appropriate functional interface, and we can use that. And these functional interfaces are so versatile, and they cover most of the use cases. In fact, in general, we may not need to create a new functional interface. We may simply reuse one of them depending on the use case. So we will be discussing one of them, which is known as the supplier. So the purpose of the supplier functional interface is to supply values, to return values. It acts as a factory, and we can use the supplier functional interface as a replacement of, for example, factory. We can use the supplier to simplify the traditional factory pattern. So there are many types of supplier functional interfaces that we can find in the java.util.function. The one is supplier, which is basically the generic supplier. Then we have primitive specialization, for example, int supplier to return the integer values, long supplier to return the long value, so that we don't have to box and unbox everything, and we don't have to deal with the objects. We can simply use the an appropriate primitive specialization of supplier that will basically reduce the overhead of boxing and unboxing and creating the objects, because they deal directly with the primitives. So let's move on to the supplier. This is, you can see the package is java.util.function. So this is in the JDK library, and we know it's a functional interface because we see the annotation functional interface, and because it has a single abstract method. And it says that it represents a supplier of results, and there is no requirement that a new or distinct result be returned each time the supplier is invoked. So the supplier has a single method get. Whenever it is invoked, it returns a value of type T because it's a generic supplier. We are going to use this supplier, and we will see how to use the generic supplier. Now T could be anything. T represents a type. We can create a supplier of string that will deal with these string values. We can similarly create a supplier of integer to deal with the integer values. Now on the left hand side in the supplier demo, we have the main method, and we created a new method which basically returns the string with name some string, but it accepts a supplier. Now we replaced the T with string, so this supplier represents a supplier that deals with string values. So whenever its get will be called, it will return a string. Now it could be anything. The important thing is, if we see the supplier, it does not accept anything. The get method, it does not accept anything, but it returns a value. That is the job of supplier. Now in order to use it, what we can do with the supplier is, we know that the supplier returns a value. So in this method, we will simply do return supplier.get, because that's the only method present in the supplier. Now how do we use it? How do we return the actual values from a supplier? To use it, what we can do in the main method, we know that we have to call some string method, and it will return some string value. So we can create a temporary variable to hold the value, and we can simply print it. Now the missing thing is, how do we pass a supplier? Now we know that supplier is a functional interface, so we can pass a lambda expression that will satisfy the supplier, and we know that it must be of type string. It means whatever expression we provide, it must return a result of type string. So that's what we are going to do. We know that it doesn't accept anything because get method doesn't accept anything. So we know whatever lambda we do, right, it will not have any parameters. So the parameter section is empty. then comes the arrow sign, and then comes the body. Because we need to return some string and it doesn't accept a value, so we may return anything. Just for the sake of the example, we may simply return a hard coded value. Let's say hello. I need to correct the data type. So now what we are saying is that we are passing a lambda expression that simply returns a hard coded value hello. Now when we run the code, it will be replaced as the implementation of get method, so that when some string calls the supplier dot get, the supplier will return the result hello, and then we should see the output on the console. So let's run this code. And we see the hello on the console. So that's a generic supplier of type string. Now it's possible to create suppliers of different types. So for example, let's say we have another example. Let me copy the method. And this time, let's return the double. In order to do that, we have to change the type from string to double. And random. Let's name it random. So what we intend to do is we expect a supplier of type double. Now because the type is defined as double, so that is the only thing that it can return. The type must match, which is double. So the method is returning a double. Now how can we use it? So we will call random method and we need to pass a lambda. So again, because it doesn't accept anything, so the parameter section is empty. Then the arrow sign, and now the body. Now let's say what we want to do is we want to call the random method of math class, which simply returns a random value, which is the double. As we can see, this is a static method in the math class which returns a double and it's a random value. So if we run the main method, we see a random value. So we created two suppliers, one of type string and second of type double. And if we focus on the second method, second supplier of type double, we know that the supplier is a generic supplier. So we provided a type of double. The only problem is here, just because we are dealing with a double value, we had to create a double supplier, and this double here is a wrapper. So what the runtime will do, it will box in and box, and similarly the compiler will do the same thing. To avoid the boxing and unboxing and to deal with the objects, we have the primitive specializations in the JDK, that is int supplier, long supplier, double supplier. So for example, we can do the same thing, this random method, instead of doing creating a supplier of double type, a generic supplier, what we can do, because we are dealing with the primitive, so we want to avoid the boxing and unboxing over it, so we can simply use the double supplier. All right, all we need to do is we basically need to change the type from supplier of double to double supplier, and it has the method get as double. We don't need to change the lambda expression because we are still returning a double value. The only difference is now that we are using a primitive supplier, so we don't need to box in and box, although we were not doing that earlier as well, but that was done by the compiler and runtime in the backend. But now because of the primitive specialization, a primitive supplier, that can be avoided. If we run the code, we see the same thing. There is no change in the output because it's a random method, so we see a random value, but the point is the behavior remains the same. Similarly, if we have to work with integer values, so instead of creating the supplier of integer like this, we can simply create the primitive supplier, which is int supplier. And we can do something like this. It returns an integer value, and we can simply call the int supplier, and it has the method get as int. So the double supplier has get as double, int supplier has get as int, and if we run the code, we should see the value 8 on the console. So you see the value 8 on the console. Now that's pretty much it on the suppliers. That's how we use the suppliers and the very different variations of the suppliers. That's it for now. Thank you.